Can you solve this problem?
There is no way we are going to multiply everything out, right? I'm already tired just thinking about it.
Exactly. Raising 7 to the power of 2026 would be way too hard. So let's experiment. Starting from 7 to the first power. What is the last digit of 7 to the first power?
That would be 7.
Right. Then how about 7 to the second power?
7 times 7 is 49, so the last digit is 9.
Good. Then what about 7 to the third power?
That would be 49 times 7, so yeah, this is where my brain starts to slow down.
At this point, the calculation starts to take some time, but think carefully. We only need the last digit, so we only need to multiply the last digits. Do you see why? Take a look at this long multiplication of 49 times 7. The 4 times 7 part does not affect the ones digit, right? What determines the ones digit is only the multiplication of the ones digits. In this case, that means 9 times 7. So multiplying 9 by 7 is enough to find the last digit.
Oh, I see. 9 times 7 is 63, so the last digit is 3.
Nice. Then what about 7 to the fourth power?
Since we only care about the last digit, 3 times 7 is 21, so the last digit is 1.
Great! What do you think happens for 7 to the fifth power and 7 to the sixth power?
7 to the fifth power would be 1 times 7, so 7. And 7 to the sixth power would be 9. Wait, it's back to the beginning. It's repeating.
Exactly. We're only multiplying the previous last digit by 7 each time, so the last digit keeps repeating in the same cycle.
So the pattern is 7, 9, 3, 1, and then it starts over.
Right. And how many numbers are in that pattern?
4.
Good. That means the last digit repeats every 4 powers.
So we don't actually need to calculate all the way up to 7 to the power of 2026.
Exactly. Here's what we get when we list the powers of 7 and their last digits in a table. We just need to know where 2026 falls in this cycle of 4.
Okay, but how do we know that? How do we know where 7 to the power of 2026 falls in the cycle?
So we look at the remainder when the exponent is divided by 4. For example, if the remainder is 1, what do you think the last digit will be?
If the remainder is 1, it's 7.
Right. And we can think about the other cases the same way. If the remainder is 2, the last digit is 9. If the remainder is 3, the last digit is 3. If the remainder is 0, the last digit is 1. I've summarized this in a table. It shows the remainder when we divide the exponent by 4 and the corresponding last digit. So what is the last digit of 7 to the power of 2026?
2026 divided by 4 leaves a remainder of 2. The answer is 9.
Perfect. You've got it now.
That's amazing. We didn't have to calculate the whole thing at all.
That's one of the best things about math. Once you find a pattern, everything becomes much easier.